Okay, Assalamualaikum dan salam sejahtera. Kita sambung sedikit saya lagi berkenaan dengan Rankine half body ni. Okay, Assalamualaikum and good afternoon. So we go for tutorial for Rankine half body. So first, how do you test for given function psi, whether the flow is rotational or irrotational? So I think you know how to answer this one. And then we have question B here. A half Rankine body formed as shown below, a source located at the origin, 0, 0 here. So this is source. And it's subjected to a uniform flow of 7 meter per second. So we have a U here, 7 meter per second in the X direction, means X direction in terms of +1 from left to the right. So, and then we need to calculate, determine the strength of the source, the distance of stagnation point from origin B. Okay, so mean for this one, B. The width of half body Rankine. Okay, please remember, we already discussed about the width of half body Rankine. The resultant velocity at point A. And if the velocity of a uniform flow increase, so what happened to the dimension of B and H? Okay, so this is the question. So here in this question, we use a linear flow in positive direction. So mean the flow is from left to the right. So and then the biggest difference is actually the value of psi combination. So it is, as I said, psi combination value is not necessarily equal to 0. So you need to calculate the value of psi combination. Okay, so we go for this one. The answer, okay, I skip for question A because you already know how to determine whether it is irrotational or rotational flow. You can check the zeta, whether it is equal to 0 or not. Okay, for B, first, when you have a situation, what you need to do is you need to calculate, or you need to express the combination terms. So here, the combination is the combination of linear and source. So, and then the linear here can be expressed as UR sine theta. Please bear in mind that we are using positive direction because the question gives us a positive direction. So, and then the source here is m theta over 2 pi. And finally, we could get psi combination here as this term. Okay, so here the value of m here is the strength of source, but in our question it is given as q, so you just replace the value of m here with q. Okay, just to make sure that we answer the question. So okay, so and then at this stage, okay, please make sure that you need to calculate what is the value of psi combination. You cannot simply assume psi combination is equal to 0. It is totally wrong. You need to calculate at any combination work, whether it is source plus sink and so on and so forth, you need to calculate what is the value of psi combination. So here what you need to do is, again, you just imagine that this is a curved line. So you have an equation. So this is the equation of our psi combination. And then we substitute with any point on that point. Mean sebarang titik di atas garisan tersebut, awak masukkan koordinatnya di dalam persamaan psi combination yang awak ada. So insyaAllah awak boleh mendapatkan nilai yang tidak diketahui. Okay, however, you cannot just simply put R0, R pi over 2 and so on and so forth, because you cannot just simply substitute the value. You need to understand the movement, the combination. So here, so this is the origin and this is the stagnation point. So means that you cannot assume that this angle is equal to 0, because 0 angle always calculated, always measure from this side. So here actually the theta here is actually equal to pi or 180 degree. So what is the distance of this one? So we could assume that the distance of this one is equal to r, which is the radial length. So that's why in this calculation, we substitute the stagnation point coordinate as r pi, because the location of stagnation point is not r0 anymore. Okay, you must imagine that for this situation, so the coordinates here, okay, is r0 because we are measuring the angle from this axis. So for this situation, okay, the angle here is actually 180 degrees. So we substitute the value of r pi here, and we could calculate that the value of theta, the value of q here is equal to q over 2. So and then we could write our stream function combination here is ur sin theta plus q theta over 2 pi equal to q over 2. So this is the final combination stream function for that specific situation. Okay, please bear in mind to calculate the value of r value of psi combination every time you do this topic. Okay, now let's say we want to calculate what is the value of Q. Okay, let's say we know that this is the psi combination equation. We have UR sin theta plus Q theta over 2 pi. So and then again we could use any point on the psi combination. So we found that the coordinate of 3 pi over 2 is suitable to calculate. So let's see the coordinate here. Okay, so the value of psi combination actually express the value of this one. Okay, so this is the psi combination. So the most appropriate value is actually the value of 0, 3 here. So because we know the distance here is 3, so means the r here is r equal 3, and the angle it can be measured or can be predicted as 90 degree. So means that the location here can be right as 3 and pi over 2. So we just use the coordinates here, then we could get the value. So in this situation, okay, please do not use the value of 4,6 here, because the value of 4,6 here is just added without any investigation, because I want you to understand how to calculate that. Because the value 4 here may be correct, but the value of 6 here is not correct. Okay, I'm sorry. So if the coordinate here is correct, so you may use the coordinate of this one. Okay, untuk perkara ini saya harap awak tidak menggunakan koordinat 46. Kerana koordinat 46 ni saya just letak aja. Jadi maknanya koordinat 46, 6, nilai 6 tu salah sebenarnya. Okay. Sekiranya nilai 46 ini benar, betul, awak boleh mengira kedudukan lokasi ini dengan cara berikut. Pertama, awak kena faham bahawa in polar coordinate, the coordinate is written as r and theta. So the value of r means the distance from here to here. So jadi awak boleh mengira nilai ini dan nilai ini. So awak kuasa duakan punca kuasa untuk mendapat nilai r. And then if you know the value of y, the value of x here, for sure you could calculate the value of theta. Okay, cuma di dalam contoh ini, saya harap awak tidak menggunakan koordinat ini, kerana koordinat ini saya beri setelah soalan ini siap. So jadi saya tak dapat pastikan koordinat 46 itu betul atau tidak. Okay, saya cuma nak tunjukkan satu perkara yang lain saja berkenaan dengan koordinat 46. Oleh itu, nilai yang terbaik adalah nilai kita menggunakan nilai 03, kerana kita boleh mendapat nilai koordinat dengan mudah. So jadi apa yang kita buat? Okay, we substitute the value of 3 and pi over 2 into this question. So finally, we could get the Q here is 84 meters square per second. So in this situation, it is okay for you to have unit of meter square per second. Kerana apa? Because we assume the thickness of that flow is equal to 1 unit. Okay, but in some question, they will give you the value of Q here by m cube over second. So in this situation, so you just calculate everything as usual, but you must assume that the width is equal to 1 meter. So that's why the meter here will give you the cube, the kuasa 3 tu. Kerana dia beri dalam meter. So in our topic here, we will use width is equal to 1 unit. So the unit here cannot be expressed with any unit, so it will disappear. Okay, something like that. Okay, because in some textbook they will use meter cube per second, in some textbook they will use meter square per second. Okay, so this is the idea how to calculate the value of Q. Okay, in this question kami saja je beri Q, tapi awak kena faham Q ini adalah sama dengan M, the strength of source. So and then let's say we need to calculate the distance of stagnation point from the origin. Okay, so normally if we solve problem about stagnation point, it is advantage for us to express or to use the equation from the velocity. Why? Because in stagnation point, we know that the characteristic of stagnation point is the velocity will become 0 because it is stagnant. So because we are using polar coordinate, so we have UR and we have U theta. So and then if we determine the value of UR and U theta according to the Cauchy-Riemann equation, so we have d psi over r d theta, we do this integration and then we do this differential. Okay, and then we could get UR is equal U cos theta plus Q 2 pi R. So, and then for U theta here, okay, we use the idea of Cauchy-Riemann equation, and finally we could get U theta, it is equal to negative U sine theta. So in this situation, for sure, we need to use this value because we are now calculating the value of R. Okay, so in this equation, there are no R, so mean it can be used to find R. Okay. So and then we have this equation. Okay, we have this equation. We equalize it with 0 because in stagnation point, the velocity is 0. So if we equalize that, and then we solve the problem, so we could get R is equal Q over 2 pi U. We substitute everything, so we could get the value of R is 1.91 meter. So means that we have the origin here, so this is the Rankine half body, so mean the distance here is 1.91 meter. Okay, please make sure that you should know the meaning of each term in our calculation. So this is the value of R. So and then the question is to calculate the width of Rankine half body. So we know that the width of Rankine half body is actually y asymptote plus at time 2. Okay, because it's double the value. So and then we know that psi combination can be written as this one. Okay, please bear in mind that we already calculate the value of Q over 2 here. So please do not simply equal to 0. Okay, and then, so this is the trick. Okay, we have half body Rankine like this. So we have a linear. Okay, y asymptote is actually the y axis. Okay, but in this equation, we do not have any y or any x. because you must know that y is Cartesian coordinate and r and theta is polar coordinate. Now we have term of psi combination in polar coordinate. So make sure, for sure, it doesn't have a y and x. So, but how to find the value of y? So we know that from this simple diagram. So if this is the radius, so we could get that the y is actually r sine theta. So this is actually the very basic idea. So according from this equation, we have r sine theta term. So we have term of r sine theta here. So we rearrange the equation. We could write as this one. So r sine theta, which is equivalent to y, and it is equal to q over 2u minus q theta over 2 pi u. Okay. I hope you could understand this idea. Okay, it's very simple. And then, okay, you need to understand about the value of Q here. Okay, in this situation, we not substitute the value of Q is equal to 2 pi. Okay, that's because in all textbook, they will not write theta is equal to 2 pi. So it is wrong. You need to write theta is actually closest to 2 pi. Theta tidak sama dengan kosong, kita hanya cakap theta menghampiri nilai 2 pi. Ya, ataupun theta menghampiri nilai sifar. Boleh juga ni. Ni dua-dua boleh. So menghampiri nilai sifar pun boleh, menghampiri nilai kosong pun boleh. Kenapa kita kata why we make statement like this one? Because I need you to understand this idea. Okay. Kita ada Rankine half body like this one. Okay, so this is the center point, the origin. So now we need to calculate what is the width of Rankine body. So width of Rankine body means 2 times y asymptote. And according to the characteristic of Rankine half body, we understand that this tail, ekor dia ni tidak akan bergabung. So dia akan membesar. Tapi sampai satu ketika pembesaran tu agak semakin kecil lah. Okay. Oleh itu kita mengatakan bahawa andai kata kita beranggapan ini adalah y asymptote yang maksimum. So kita akan ada theta. Tetapi secara realitinya y asymptote akan menjadi besar di sini. Okay, di sini dia akan jadi besar lagi kan. So kalau kita kecilkan lagi angle ini, so nilai tersebut akan menjadi lebih besar lagi. Dan kalau kita kecilkan lagi, kita akan menjadi lebih besar. Oleh itu, kita memasukkan nilai theta ini akan, okay, maksud di sini ialah y become maximum means y asymptote become maximum value at theta mendekati 0 atau theta mendekati 2 pi. Okay, kerana saya sengaja gunakan 2 pi di sini kerana nak ajak awak berfikir. Okay, sekiranya awak menggunakan bahagian positif di sini, yang bahagian atas ni, so kita akan mengatakan theta akan menghampiri 0. Tetapi anda kata awak mengira yang bawah ni, maknanya awak theta di sini satu nilai, theta di sini satu y asymptote dan seterusnya. So, jadi kalau kita makin jauhkan lagi, kita kata theta di sini, okay, bukan menghampiri kosong, theta di sini adalah menghampiri 360 darjah atau menghampiri 2 pi. Okay, saya cuma nak ajak awak berfikir supaya awak faham pengiraan angle dengan betul di dalam topik ini. So, jadi di sini saya harap awak dapat imagine, awak dapat faham bahawa kita tidak boleh masukkan nilai theta sama dengan kosong. Okay, kerana kita beranggapan bahawa kalau masukkan theta sama dengan kosong tu, seolah-olah kita mengambil satu garisan di sini. Okay, sebenarnya ia tidak memberi nilai yang tepat. Maknanya kefahaman awak itu rosak sedikit lah. So, jadi awak kena faham bahawa theta kita akan menggunakan dengan idea menghampiri. So, kita kata kita masukkan theta sama dengan kosong ataupun theta masukkan dengan 2 pi, both are correct. So, awak kalau masuk theta sama kosong, awak still ada Q bahagi 2U. So, Q bahagi 2U, so awak akan dapat 6. 2U meter 14 darab 6 masih lagi 84. So awak akan dapat. Okay, di sini kita akan dapat negatif 6. Okay, saya sengaja menggunakan 2 pi di sini kerana apa? Pertama, nak memahamkan awak kedudukan angle. Kedua, sekiranya jawapan awak mendapat nilai negatif, awak kena faham nilai negatif ini sebenarnya ialah, okay, I'm sorry, this is okay, ni bukan R ni equal to Y, sorry. Okay, nilai negatif di sini sebenarnya hanya reflect kepada kedudukan ataupun ketinggian nilai Y ini di dalam paksi Y yang negatif. Okay, oleh itu, in final answer, you should write as the width of half body Rankine is actually 12 meters. So, awak kena positifkan nilai tersebut. Okay, so boleh nampak kerana di dalam graf kita ada negatif positif. When people ask you about length, so length is not a vector, so the magnitude is not counted. So you just take the absolute value of that one, and then you multiply with 2 because we want to calculate the value of width of Rankine half body. Okay, saya harap awak dapat imagine yang ini. Dan seterusnya kita pergi untuk soalan seterusnya. So resultant velocity at 0.46. Okay, please bear in mind in this question the value of 46 is actually given later. So this cannot be used to calculate the value. So to calculate to be used in previous question. Okay. So in this question, I would like you to calculate the resultant velocity at 0.46. So and then from Cauchy-Riemann equation, I'm sorry, a typo here. A Cauchy-Riemann equation, we could calculate the value of UR and the value of U theta here. So what we need to do is we could calculate the value of R, which is here. So and then we could calculate the value of theta according to this triangular diagram. So and then we will use that one. Okay, we substitute into this R and theta, and then we could calculate that UR is 5.74 meter per second and U theta is negative 5.83 meter per second, and the resultant velocity is 8.18 meter per second. Okay, so if we write the velocity, so let's say we have a molecule here, so UR here is 5.74, let's say according to the, okay, it's quite, U theta is negative. Okay, kita lukis dalam gambar aja lah, sebab nilai R ni, okay, sebenarnya ia mesti selari daripada nilai R di sini. Okay, so katakan let's say ini adalah UR dalam keadaan positif dan theta kita kata adalah negatif ke sana. U theta adalah tangent di sini. Okay, so resultant velocity-nya adalah lebih kurang ini. Okay, tapi ini tak cantik lah, lukisannya tak cantik. Sebab lukisan ini tidak sama dengan apa keadaan sebenar. So mungkin saya rasa kat sini dia condong lagi ni. Ni R akan ada gini, ni UR. So U theta tangent dia mungkin akan sikit macam gitu. So and then dia akan resultant velocity ni. Okay, lebih kurang macam gitulah. So jadi maksudnya awak dapat imagine. Okay, awak dapat imagine bagaimana dalam keadaan ini. First you have idea to calculate the value of R and theta from the location of Cartesian coordinate. And then I hope you could calculate the component velocity and also the resultant velocity. Then you could imagine how this component velocity acts on that particular point. So and then, okay, and then you need to calculate, you need to know what happened if the value of B, what happened to B and what happened to H, okay, if the velocity increase. So in this question, what you need to do is you need to come with a reason. You need to answer this by showing equation and evaluate that equation and answer that. Awak tak boleh just nak kata, okay, kalau velocity meningkat, B menurun atau B menaik. So, tidak ada markah untuk itu. Awak kena membuat conclusion atau memberi alasan ataupun menunjukkan bukti dari mana nilai B itu boleh meningkat. Okay, contohnya, okay, sekiranya diminta apakah yang akan berlaku pada B, okay, sekiranya nilai U bertambah, so kita boleh mungkin menggunakan kadar alih adalah Q equal to pi RU. So yang ini saya harap awak dapat imagine 2 pi R is the parameter. Okay, so and then U is the velocity of this one. Okay, so and then U means Q over 2 pi R. So if the velocity is increased, so means that the 2 pi B, so B here, okay, will give a reverse effect. So the value of B here will reduce. Okay, so and then for B, so we know that the value of H, okay, or Y here. Okay, why I write H here? Because in the question they give us this is an H, I think. Oh, okay, let's say this is an H. Okay, dia tak tulis Okay, tapi maksudnya H itu adalah nilai Y. Oleh itu, according to this correlation, this equation, we could say that if the U is increased, so the value of Y will decrease too. Okay, so di sini cuma nak menunjukkan sekiranya diminta untuk menjawab soalan seperti ini, saya harapkan pelajar tidak terus memberi jawapan increase or decrease or not change and so on so forth. You must come out with certain reason. So reason mungkin berdasarkan teori, mungkin awak boleh mengatakan okay, berdasarkan teori kadar alih atau sebagainya, boleh juga. Tetapi dalam kes ini kami lebih prefer untuk awak comes out dengan equation, then awak evaluate equation tersebut bagi memberikan jawapan kepada soalan yang diberikan.